Good afternoon, everyone. Thank you, the program committee, again, for accepting the presentation and letting me present. I'm going to present the results of the survey of Internet Carrier Interconnection Agreements. That's very long for peering. This is the 2016 survey and is the second that we've done. It's a follow-up on a previous 2011 edition. So we're also hoping to continue doing this survey every 5 years so we can track and we can build a historical time series of this data and see how it changes. So 5 years ago, we conducted this first ever broad survey looking at peering agreements. We asked service providers those questions because we wanted to characterize them. We wanted to understand when we talk about peering agreements, what we're talking about. We wanted to know whether the agreements are formalized into a written document or if it's something that it's a handshake that we call agreement. So generally, peering coordinator emailing each other, telling each other, well, do you want to peer? Which exchange are you at? Yeah, I'm here. Okay, let's exchange, and that's it. We wanted to know whether the agreements had symmetric terms or whether the parties were exchanging different things. So we've asked that as well. That's what we asked in 2011. And also, what was the country of governing law of the agreement, and trying to understand a bit more where ISPs are more comfortable. The previous largest survey to this one was 16 agreements, very small. In 2011, we analyzed 142,000 agreements from 4,000 plus internet service providers in 96 countries. And you have the papers there on the web. It was downloaded quite a lot of times in 5 years, which also give us some measure of whether that was interesting or not. And we promised to build this survey again. Why is this something important, or why we keep doing it? This type of survey, we believe that it gives a very good insight into this model of exchanging traffic between networks. Peering is something that happens a lot. It happens a lot at the core of the internet, and it's a value creation mechanism. So by trying to understand a bit more, we also understand whether it is a practice that is well understood by service providers, and it is largely an area where there's no regulation. And we also, it's important to realize that by having peering as a practice that is well understood and recognized between service providers, it would have been much more difficult to agree between different regulatory approaches between countries that are very diverse. So this is like a very positive, and we're trying to understand how they work, those peering agreements. So we published on 2016 the results, and in addition to the questions that we asked in 2011, we added a fourth question, and this was basically a demand from you guys, from the service providers, and we wanted to know whether that agreement, that peering agreement, if you were exchanging V6 traffic. Imagine the way in which this was organized was that every service provider could send us a very simple CSV file that he could generate out of his peers. So in every row would be one peer, a yes number, and then a yes, no, or true, false in different columns. So that helps service providers to participate in the survey, because it's not a heavy overhead for them. And that also allows us to produce, scripts and data processing software to analyze the results. Just to give you an idea, I imagine that some of you here would have participated because we had a very good turnout of answers from Russia. So you might be familiar with these already. So this time, 2016 survey, we analyzed almost 2 million interconnection agreements, and they do represent more than 10,000 carrier networks in 148 countries, and that include 35 OECD countries and 21 least developed countries on as defined by the United Nations. This graph shows the geographic distribution of the networks represented in our data set, and a darker shading indicates a larger absolute number of networks represented. So as you can see, we had very good turnout in Russia, in the United States, in South parts of Europe. The reality is that because this is not normalized to the number of by the number of carriers, in some of the countries that look very white, we actually have 100% coverage. But if you compare in volume with other countries, they appear very white. So some of these graphs and figures are a bit difficult to interpret, and that's why I'll try to stop and give you an interpretation. But if you have time and you're interested, there is a full kind of paper study that is on the website. So besides this presentation, there's and that goes slowly and more in depth into this. So what is the representation that we had? In this graph, we have the top 30 countries of incorporation that are represented in our data set. The red line describes the number of networks represented in the data set. The darker blue area indicates the number of transit networks, and the lighter blue, the total number of networks, including non-transit. And with these, we want to show that we do have a good representation of some transit providers. So we're not looking only into smaller networks that would do a lot of peering. We're also adding large networks, large transit providers into our data sets. Of course, we have, as you could see from the previous figure, the US, Russia, UK, Germany, and Indonesia. We received a large number of responses. We have a low coverage for some countries, and they're significant size. Some of them are India, Romania, and Thailand, and this is something, again, that we try to improve and we'll hope we'll be improving in the next survey. One of the surprises that we will see a little bit later is Indonesia has moved into the 5th position, and it is related to the fact that it's the 4th largest country by population and the 16th largest economy, and this has also shown into some of the practices, particularly around multilateral peering agreement. So we're going to do a deep dive into that a bit later, but it is something that we wanted to I wanted to highlight. So of all the 2 million agreement, 955,000 comprised matching pairs. So the two sides of the agreement sent us the agreement, and in 98% of those cases, both parties answered the same, which means that they both understood what they were asked, and that also helped us to take this survey more seriously, because we know that what they answer from both sides is the same. So there's a slight decrease from a 99.52% 5 years ago, and we attribute that to the fact that we added a new question. And when you add a new question, you have more possibilities of having disagreement between what each pair says. And in addition to the survey, in order to get more clarity, we've conducted unstructured interviews with 35 of these networks, sometimes trying to get some clarification and sometimes trying to build up a bit more, checking whether the results they felt that were representative to the current situation. So we're moving into the findings. This shouldn't be no surprise to any of you, but we found that the 99.93% of the peering agreements are informal handshake agreements. Both parties understand the terms of the agreement, and this is up from 99.51%. So written contracts are very rare and becoming more and more rare. They do exist, but they tend to disappear as the relationship continues. A contract expires, and then nobody, renews the contract. So this is something that we're seeing happening. As I said on the disclaimer, even though there's no the main backbone providers are represented on the survey, so we believe that this is something that can be understood as a global practice and a global trend. 99.98% of the peering agreements had symmetric terms. So each party was exchanging, gave and received the same conditions as the other. I wanted just to clarify, here we're talking about interconnection agreements. We're not talking about traffic and about volumes. We're talking about agreements to become a peering partner, an interconnect. This is up from 99.73% in 2011. And that also contradicts another notion that comes from some of the market dominant, large incumbent players, that they advance a certain notion that paid peering are very common and they happen a lot. They do exist, but the number decreases as opposed to the number of the overall growth of these symmetric agreements. So there are still, if looking at the country of preference for contractual country of governing law, we're finding that there's a certain parallelism perceived by which other countries where there's more the legislation and the policy and regulatory prevents ISPs from being liable from content. So in this scenario, countries like the United States, Canada, and Japan remain favored as a countries for governing law of these agreements. And Romania, Ukraine, and Russia continue to be selected least often, with China and Thailand joining this year near the bottom of the list. This will be a graph showing what I just explained. You have to believe. So you have the most selected countries on the left, the top 1, 2, the top kind of 8, 10, and then the less selected countries on the right-hand side, and then in the middle would be all the rest of the countries. So this is this doesn't. I don't think that this should be surprising. This is not surprising, and this still reinforces the notion we had from the last survey. Another key finding we found is that nearly all peering that we've seen in our data set is multilateral peering, and it's implemented through route servers and multilateral agreements. And these, we've already seen that in 2011, it was starting to become a dominant practice, but in this last year's survey in 2016, 5 years later, we see that it accounts for the vast majority of the AES agencies that we have. And why does that happen? Well, multilateral agreements are very easy to set up. You just need to do it once. You get into an exchange, you peer with everyone, and not only that, but once you've done it, subsequent service providers that join the exchange automatically have that session with you as well. So we find that is a trend that was already present in 2011, and that now it clearly shows that it is here to stay and to keep growing. And we will see in some of the graphs that some of the countries are very, they show these very clearly. So if looking at the answers, and we do a bit of a deep dive into the interconnection partners per network, we could see these role of the multilateral peering agreements represented in this graph, and they are represented as spikes. So these spikes that you see represent these multilateral peering agreements. Let me tell you a bit more about the axis of that graph. On the this is a distribution of number of networks on the y-axis, with each quantity of interconnection partners on the x-axis. So the way of looking at this is that you have 150 networks that are interconnected with 418, or have 418 interconnection partners, and that will be represented by that big spike of the Moscow MLPLA. You continue a little bit further, that will be, for instance, London, and if you continue a little bit further on, you'll see a big spike by 1021, which is exactly the number of partners at the Jakarta Internet Exchange. And that is one of the multilateral peering agreements, one of the largest ones, and that's one of the reasons why we've seen Indonesia moving up into the previous graph. If we do a bit of a zoom in into that particular area, this is where we can see that about 102 networks will be only present in that particular exchange in Jakarta, and we'll have only one peering agreement with the route server at the MPLA in Jakarta, and that will be these 1,020 interconnection agreements all at once. So this is a way of looking at this graph. It's if you start looking at the other bars, those bars will represent basically networks that are peering with a route server, and maybe they have 2 or 3 other peering agreements with other networks, and they appear that they have 1,022 or 1,023. So this is the way of interpreting this particular graph. Countries that benefit from MLPAs, from multilateral peering agreements. So we've represented the top 30 countries that benefit most from LPLAs, and we're showing the number of MLPAs, in the country. So that would be the bars. So you can see Indonesia has 2, you have Germany with about 10, France has 2, UK, so that will be the way of reading it. The red line will be the networks participating at that particular multilateral peering agreement, and the light blue area on top is the number of adjacencies. And this is another way of seeing that as what we call donut peering was overtook tier 1 peering in the late 1990s. Multilateral peering has now overtaken bilateral peering in number of AES adjacencies. So that's important to see the trend and to see that some of the countries that have large exchanges with route servers enabling these multilateral peering agreements are having networks benefiting from a high degree of adjacencies, or from a larger number of adjacencies. If we go into, you remember we had a question of IPv6. So this is where things get, we don't have such a good news. Only 3.88%, so 72,000 of those agreements were exchanging IPv6 traffic. This is not good. We wish to have better results. Of the 30 most represented countries in our data set, Russia has the highest average rate of IPv6 routing. So congratulations, guys. For all the Russian networks that are here, you're doing very well, followed by Ukraine, 10%, Brazil at 6%, and the United States 4.7%. And every other country that we received in our data set, again, this is our data set, in the top 30 fell below the global average of 3.88%. So this will be, again, a graph that shows, you can see the two-letter acronym of the country and whether they are above or below the average. Now, how does that relate? Do small networks and large networks have the same values? Is there something else we can say? So of all we found that there are large discrepancies between large and small networks. And very large networks, of the dozen of those very large respondents that were routing IPv6, on average, they were advertising more than 100 prefixes each. And they supported IPv6 with nearly 70% of the peers. This is very high. It's very good, right? However, if we look at the other side, at the smallest of the 50% of the responders, 92.5% had no IPv6 peers or prefixes at all. And they averaged 0.42 IPv6 prefixes and supported routing with 0. So nothing. So again, the picture, averages mean something, but then if we do a bit of a deep dive and we try to understand, we can see that large networks have a very different behavior than smaller networks, and that smaller networks are lagging a little bit behind. One of the things that we wanted to do is we tried to make a parallel and see whether these results that we received through the peering survey on the internet connection agreements, they could somehow reflect or be reflected on the percentage of IPv6 traffic at some of these exchanges. This is a screenshot of the exchange directory that we maintain at PCH, and we've added a column that is IPv6 that represents the percentage of traffic that is V6 from the total traffic exchanged. And we could see some degree of correlation. I wouldn't say that is a high degree, but some degree. So you could see, that in MSK's IX in Moscow, there is at the moment where we made the screenshot and we did the analysis and the presentation, 17.5%, and by our survey, we got 21. So it seems there might be some correlation. This is something that we're doing together with exchanges, where we're offering them to publish the data on our directory and try and encourage exchanges to also publish V6. Thank you very much. V6. So the rest of the world can see how they're doing, and we can see, hopefully, more and more V6 traffic flowing through exchanges. We also try to graph correlation between IPv6 routing and GDP per capita. We know sometimes that levels of GDP, they can follow sometimes industrial development, and sometimes it does correlate with infrastructure, investment in infrastructure, broadband. So we try to do these experiments. As you can see, there's not much I can say. It's a big mess. There's no story to tell here. So you have networks with high level of V6 that are with low GDP. There's nothing. There's nothing really we could find. There's some pockets of geographical that they seem to have some similar conditions there. Russia and some of the neighboring countries and Baltic states, they seem to have a high or higher levels of IPv6, and they're about on the same GDP per capita, but besides that, we can't really say much more. So we're getting into the end, and one of the last things that we've done was to look at the number of interconnection, so domestic and international agreements, and how countries had those. So looking at the frequencies in which pairs of countries of incorporation appear within the data set, it was possible to chart the relative number of connections between any country and all the others. So basically, here in this figure, we have the ratio of domestic interconnection to international interconnection, and darker shades indicate higher ratios. White means that we don't have enough data. So there are a couple of things that we could say, but this is a complex, and there's a strong interplay between the amount of bandwidth that is produced in a country and the amount of domestic consumption of all that bandwidth. So countries that have both large domestic bandwidth production with a lot of exchange points, a lot of service providers, and large domestic consumption tend to be internally well connected. So for instance, in that figure, the United States, Russia, Brazil, Indonesia, they fall into that category, and and they're very dark, not because they have very little international connectivity, but because they have much, much more international connectivity. So that is one way of looking at this graph. Finally, so if we look at those pairs and how the interconnection between the nationalities of one network's interconnection partners, and we will start with a kind of a typical figure. This could be kind of a typical graph with a certain amount of domestic partners within your country, and then several countries in which you generally have the internet, at some extent, also mirrors the trade relationships and international relationships. So you'll have the United States will have Germany. 11% of the interconnection agreements will be with German networks or with Dutch networks, with English, French. The small pie relates to IPv6, so you can see how different it can be. So this will be a little bit kind of a typical case. But if we look at, for instance, Russian networks, what we can see is that it has more than twice as many domestic IPv4 connections as the United States, and more than 25 times as many domestic IPv6 interconnections. And this success of having such a large domestic mesh of partners is primarily to the numerous large exchanges, each of which has a multilateral peering agreement with a high rate of participation. So what we were discussing before, and the role and the trend of multilateral peering agreements, it showed here again. We've plotted also UK and Germany, because they are the 4 countries, US, Russia, Germany, and the UK, that will receive more respondents. And you can have a look both at the ENOG side and the study. You can see again, that's the American. You could see the British again. There's a 33% of domestic for V4, and then you have a number of partners that generally represent countries where there's a variety of relations. Generally follows a certain trend of trade and sometimes not only trade, but it could be linguistic associations or so. And that would be for German. Finally, sorry, Indonesia, we were talking before. With Indonesia, you could also see, based on the data set and our respondents, that almost 50% is domestic. This is also due to the large amount of answers we received and they represent, they somehow show the impact and the trend of multilateral peering agreements now in the future. Thank you very much. Thanks for your attention. As I said, I'm here around. The slides are on the ENOG website, and the study is on our website in case you want to expand.